Today we're going to be talking about CameraX. But before we start, I was curious, how many people here are using the Camera 1 API right now for their applications? Okay, some people. How many people are using the Camera 2 API? Oh, interesting. Some people are using both. So hopefully after this talk, we can convince you that you're going to be really excited to use the new CameraX library. So it's pretty much a common opinion that camera development on Android can be really difficult and frustrating. So one of the reasons that camera development is so frustrating on Android is because of the fragmentation on Android, right? And the main thing about the fragmentation is API versions. So one of the things that I realized when I was developing my camera app was that I had to do a lot of if-else statements or switch statements to make sure that, hey, if this application is running on API 21 or API 19, I had to do something different to do something different. The other thing that's really hard is providing consistency across devices, right? Because a lot of times I realize that even though the camera hardware reports that it's doing something, for example, a Samsung phone thinks it has a flash enabled, but it doesn't actually have flash enabled. Or a Huawei phone thinks it has certain capabilities when you query the API, but when you actually try it, you realize, oh, they're just kind of lying to you about their APIs. And the last thing that kind of manifested itself when I asked people how many people are using the Camera 1 API and the Camera 2 API was that the current camera API is really complex and frustrating to use, and it could be really difficult to just try to set up to do simple core cases. So this is where the CameraX support library comes in to kind of help everybody solve these kind of problems to make developers' lives easier in developing these camera apps. So the CameraX library, in a nutshell, the cool thing about it is that it's backwards compatible up to L. So that means that if your app is targeting L, it's compatible up to 90% of devices. So that's a lot of devices out there that your camera app will be available for. The other cool thing about it is that if you're using the CameraX support library, it creates a very consistent behavior across devices. So the way that we provide this consistent behavior across devices is that we realized a lot of camera developers were testing their camera app themselves. So they had like 100 phones in their company, and they're testing all these different kinds of devices on different API versions just to make sure that their app was working. So Google created a camera testing lab. So they have thousands of devices running on different kinds of APIs, literally running tests 24/7 to make sure that the camera API is doing what it's supposed to. That way, we're congregating all the testing in one place, so everybody doesn't have to do their own testing on all these different kinds of devices. And lastly, the CameraX library provides really easy-to-use APIs. So one of the frustrations that we heard from developers was that it's really difficult to get things set up. Camera 1 API is really easy. It's like a point-and-shoot camera. It's really easy to get something going, to make capture. Camera 2 API is kind of like using an HDR camera. You have a lot of functionalities. You could do a lot of fine-grained control, but it's really hard to set up, and it's really hard to get things going, even if you just want to do a simple capture. The cool thing about the CameraX library is that we found that for developers who are using the CameraX library, it results in using 70% fewer lines of code versus Camera 2. So Caren is great. It gives you less lines of code, but CameraX is even cooler because you can reduce your lines of code by 70%. So now we're going to jump into some of the core use cases for the CameraX library. Three main ones are preview. So this is when you want to show a live preview of what the camera is seeing. Second one is image analysis. So if you want to do a frame-by-frame analysis of what the camera is seeing. And the last one, most important one, is capture. So the first one we're going to look at is the preview case. So configuring a preview, the first thing you want to do is you want to configure how you want this preview to look. So this includes things like setting the target rotation, setting the target resolution. And the great thing about this is that when you're building these configurations, we actually try to look at what camera or what device your app is running on, and we try to look at what kind of state the current device is doing, and we try to do all these configurations for you. So we try to do everything for you by default, so that you don't have to do any of the hard work. But if you wanted to do some more fine-grained control, you could set your own stuff. So in this example, even though we're setting the target rotation here, it's actually already set for you by default. So you don't have to do this, but if you wanted to have some fine-grained control, you can. So once you've created the configuration, you want to create the actual use case. So we pass in the configuration into the preview use case, and this way we have a use case that's ready to be used. Once we have the use case, now we can actually attach a listener to it. So this is what happens when we say, oh, OK, so now we actually have some frames ready to be previewed. And we set the configurations for it. We know what's going on. So now we're actually ready to attach this to a surface texture so that we actually could show this preview to the user. And the last cool thing about the preview use case is that once you have all this configured and ready to go, you can bind it to a lifecycle. So this is great because in the previous camera APIs, we had to worry a lot about when you open the camera versus when you release the camera so that you don't cause any errors. When you bind to a lifecycle, all this is handled for you. So what this means is that if you bind to a lifecycle of activity, once the activity starts, the camera will open by itself. And once the activity stops, then we'll release the camera for you, so you don't have to worry about all of that as much. So this is a general overview of what it takes to set up a preview. So this is almost all it takes for you to show a preview of the camera for the user. You might have to do some extra stuff like handling camera permissions or setting up the texture view, but in general, this is the base lines of code that you need in order to set up a preview. So the second use case we're going to look at is image analysis. And this part is really cool because this wasn't really available in previous APIs. I think in previous APIs, you really had to just wait for new frames to be ready before you could do image analysis by yourself. So configuring for image analysis is very similar to configuring for a preview. For image analysis, you start again by creating a configuration. And just like the preview configuration, we try to do as much as we can for you, but you also have the fine-grained control of, hey, I want to set a specific target resolution. So for example, if you want to do some image analysis that required a minimum target resolution, you can set it over here. And we try to do our best in giving you that image resolution, but some devices may be worse than others and not have such high resolution. So we try to do the best view based on what you provide. Once you have the configuration set up, again, you need to create the use case to actually start using this image analysis. Once you have the use case, then you can start setting up a listener. So what happens here is that once you have an analyzer, once you have the configuration set up and you attach a listener to it, every time the camera gets a new frame, you do whatever you need to do to the image analysis. So for example, if you wanted to compare one frame to another frame, we basically give you the whole image, so like all the bytes, in order for you to do any kind of analysis you want. And the thing you want to be careful with here is that you want to make sure that the analysis you do here can actually run fast enough so that you're not stopping frames. So this is kind of like when you're building UI, you want to make sure each frame is able to render fast enough. Otherwise, what's going to end up happening is that each frame is going to skip. You'll be doing way too much work on the analysis part. So once all that is set up, again, you have to bind it to a lifecycle. So you can see in this case, we're actually binding to a lifecycle both the image analysis use case and the preview use case that we did earlier. So we're combining the two use cases and binding both of them to the same lifecycle. This means that when the activity starts, we're going to start the camera and be ready to start both of these use cases. So this is the full setup right now to process an image. So far, what we've done is we've set up what we need to show a preview, and we set up what we need to do the image analysis for each frame. And lastly, the most important part is the capture use case. So let's take a look at that. So configuring the image capture use case is very similar to what we've done previously for the two use cases. We want to start by creating our configuration. And again, like the previous ones, we try to do all the work for you by saying, hey, what kind of device is this app running on? And what kind of state is this device currently in? And in this example, we're setting the target resolution just because we want a little bit more fine-grained control for it. But if you don't set the target resolution, in the back end, we still try to do as best as we can to determine what's best for your device. So once we have the configuration set up, we can create the use case for image capture. And again, we need to bind this to a lifecycle so that the camera gets started and stopped properly. And as you can see here, we're actually binding all three of our use cases that we talked before at the same line of code. So far, we've done all the setup to show a preview to the user. We've done the setup to get ready to analyze every frame that comes in. And we've done the setup to actually capture images. But we haven't actually done anything to handle user action at this point. So now we're going to look at how we can handle user action with all the stuff we set up so far. So in this case, we're going to look at how we can handle user action when we want to save a picture when the user clicks. So this is the common example of how do I provide a button for my user so that when they click the button, they take a picture of whatever it was currently previewing. So in this onClick method, we have a file. This file is very similar to what we've done before, where you need to specify where you want the specific capture to live. So we specify, OK, when user takes a picture, we want to save that file to this place. And then we call the take picture method, and we attach a listener to it. So once you attach a listener to it, when the take picture method is called, you either get an on error callback, which says, oh, something wrong, we don't know. The file that you specified doesn't actually exist, and we don't know where to save it. Or you get a success callback. So your image is actually saved successfully. So that was kind of an overview of the core use cases that the CameraX library supports right now. We have the CameraX sample app, where all of this is demonstrated in a real working app. So that's on GitHub right now. The other important thing that would be good to subscribe to is the CameraX dev mailing list. So this is a community of everybody who's currently developing with the CameraX library, asking questions, giving feedback. You can subscribe to the mailing list to get more feedback about what's going on with the library, how other developers are using the library so far. And there's also a specific CameraX Stack Overflow tag, where you could check to see, oh, these are issues that have been answered by Google developers. These are issues that other developers have run into and solved on their own. And now to talk more about the CameraX sample app is Oscar.
Thanks, Caren. Hi, everyone. I'm Oscar. I'm also an engineer in the Android Developer Relations team. And we want to cover some of the stuff that we had to do in the CameraX sample app to give you an idea of that real-world scenario, real-world use case. So the sample app is in the link that we just showed in the previous slide. It is available on GitHub in the new Android repo. We are looking at every single issue and every single pull request. So don't be shy. Go ham. Submit as many as you want. However, do not confuse issues with the sample app with the library. If you open an issue in the GitHub repo that is about the CameraX library, I will kindly ask you to reopen the issue in the AOSP issue tracker that is related to the Android X component. So save us some time, just open it in the right place. Now about the technical aspects of the sample. It is very basic. It is called CameraX Basic for a reason. It is designed to be as a very fundamental photography app. It allows you to take pictures and not much more. It showcases the preview, image capture, and image analysis, basically the three core use cases that Caren mentioned earlier. And then in the future, we will implement vendor extensions, so HDR, beauty mode, night mode, and so forth, as well as video record. That said, that stuff is not even ready in the library yet, so we can't go any faster than the library can. Now, one of the most interesting and tricky aspects of developing this sample was working with the preview. So we're going to go a little deeper into some of the stuff we had to do to get preview working in a reliable way. The problem with preview is that you have to handle a lot of state that is not done for you. So CameraX, as an Android X Jetpack library, does one thing very well, that is being a lifecycle aware component. So everything related to the lifecycle, activity, fragment, pause, resume, all that stuff is completely done for you. You don't have to worry about a thing. But with preview, you have to worry about different views and a lot of state changes that are unrelated to these lifecycle components. The first one is the preview output update. This is done by the CameraX itself. It's basically telling you, OK, you asked for a preview. Now it's ready. Here it is. Do whatever you want with it. That is unrelated to lifecycle components, and you have to handle yourself. Second one are layout-related lifecycle issues, mainly around texture view. So whenever it inflates and so forth, that stuff you have to watch out for yourself. We also have to look at the display. When you rotate the device 90 degrees, that's going to trigger your activities and fragments to destroy and recreate or to stop and start. However, when you rotate the device 180 degrees, it doesn't trigger a real layout. So what you'll see is that if you don't listen for the display orientation changes, you're going to find that your preview is suddenly upside down. We also have to look for camera hardware changes. Keep in mind that starting in Android P, I believe, we support USB cameras. There's nothing stopping a user from just unplugging the camera while your app is running. Why would somebody do that? I don't know, but it could happen. We also have retractable cameras now. So some of the new phones have the cameras that go on the back, and you can flip it back and down. It could happen while your app is running. You have to be ready for that. We're going to cover each one of these one at a time in a little more detail. The first one is the preview output update. Say that 3 times fast. So starting with a preview use case that you have built using the builder as Caren shown. And you have your texture view, which is the viewfinder, whatever you're going to show that preview. You set up the listener. And then the listener is going to trigger whenever the CameraX library has deemed that the preview is not ready to use. You get this preview output object. And here's the very first trick, something that's completely non-obvious. You have to remove the view and reattach it. What's happening here is that Android is trying to be a little too smart. And unless you reattach the view, there's no way for Android to know that something has changed behind the scenes. So it is trying to save some energy and trying to optimize for performance. And the problem here is that unless you reattach, it just shows a black preview. So by doing this, you're basically telling the texture view, hey, I'm about to do something on the underlying surface. Make sure that you are redrawing everything within. After you've done that, and this needs to be in the correct order, you can update the surface texture that goes underneath your viewfinder with the surface texture that is provided to you by the preview output. You basically just swap one for the other. And now you can apply the output transformations. What do we mean by this? Well, let's cover that in more detail. So we have a viewfinder. This can be your full screen in an app, or it can be a small square, or anything in between. This is basically the real estate that you have in your user's screen to display your preview. Then you have the actual preview output. This is what the camera is seeing. The resolution of this is going to be determined by the camera. It's going to depend on many factors, how many use cases you have simultaneously, what resolutions the camera supports, a number of other things. You have somewhat limited control over what comes out of the camera. The result is that you're going to have a small square that covers over the whole preview. That is a problem. You're going to see a very small window, and it may not match what the user wants to see. How do we solve this? Well, the easy way out is you can basically fit the output, shrink it to basically match your viewfinder. This results in, obviously, a squished version of the preview. I can't think of a good reason why any app will do this, but this is a valid solution nonetheless. A pretty common way to resolve this problem is to do letterboxing, aka the black bars. What we're doing here is we are looking at the longest side of the preview output, and we are matching that to the longest side of our viewfinder. And then we are centering the result. And that results in the space on the sides, which are the black bars. Another technique, this one is probably the most common one, is doing center crop. So we're doing almost the opposite of letterboxing. We are looking at the shortest side, and we are matching the shortest side of the preview output with the shortest side of the viewfinder, resizing to match, and then centering again. So just to summarize, these are the 3 different options that we covered today. In the sample app, we are doing a full bleed view. Basically, we're trying to draw every pixel in the screen with pixels from the camera output. So we are doing a center crop transformation. So that is for the preview output update. We can cover a little more about the layout. Again, these are related to the texture view lifecycle and just all the views underneath. This one is significantly simpler. You basically have some sort of view, and views have this method called onLayoutChangeListener. This is going to happen normally when the view gets inflated first, so it gets its size, and it is only after this that we can get the actual size of that blue square. So this basically is telling us, OK, my view is now being inflated. Now we have a size, and that is going to be the blue square, and now I can actually match. Otherwise, if we try to do the preview transformation before this method gets called, we are basically guessing how big is our preview. We don't know. So yeah, then again, now is when we can actually look at the size and then match the preview. So those 2, preview output and layout callbacks, are what we're using to determine the sizing of the preview and how we can match it to our screen. We still need to look at the display. So the problem with the display is that, again, when you get the 180-degree rotation, you're not going to get any other callback. You also have display removed and reattached. In our sample app, we're not really worrying about this, but imagine that you have something like a communications app, and you are showing the preview, and when the user plugs in an external screen, that may be a signal to you that the user wants to see this preview in the other screen. We're not looking at it, but you may be interested in that. So again, we have a viewfinder, and then there's a really nice way to retrieve the display in which the view is being shown. We just call the display attribute. And then we can store this display ID. I'll show you why in a second. We set up the display listener, which will then register via the display manager. In this case, again, we're not looking at whenever a display is added or removed. We don't care. We are a photography app, so we mainly want to be on the same device as the user. So to save some time, we're only acting on whenever the display changes on the same display that the preview is being shown. And now we apply the relevant output transformations. What are the transformations here? Again, if the user has rotated the device, you're going to have to apply a rotation on the preview output, so you're not upside down. But let's once again go into a little more detail. So what I mean by transformation, there are several ways that you can approach this. And they have their pros and cons, and I'll explain why we chose what we chose for the sample. So the option one is that you can apply this rotation on top of all the previous transformations. So the problem here is that you have not one, not two, but 3 different callbacks that you have to listen to, and then apply all the relevant transformations. So this is basically the classic problem on asynchronous programming, right? So the idea is that you will have to save all the previous transformations somehow, store them, and then reapply them, and then append this rotation on top of all the other transformations. It is completely valid, but we decided to go in a different way in the sample. So the option 2 is that there is a method in the preview use case. Actually, there's a method in all the use cases. What you can call is a method called setTargetRotation. What's happening here is that you are informing CameraX that your device has rotated, and now upside down is whatever the display is telling me. The nice thing about this is that when you call this, the preview output update will actually get triggered. So you're essentially manually triggering the preview output update, and then from within, you can look at either rotation degrees, which will come as one of the attributes on the preview output object, or you can simply look at the current rotation of the display in which the viewfinder is being shown. In this case, that will always be up to date because you have a display listener and you are triggering this event every time that the display rotates. So that's for the display. And then the last one is the camera hardware. This one is the easiest one of all. What we're doing in the sample is nothing at all. What's happening here is that CameraX library does not even support USB cameras yet. As of right now, we only support front and back-facing cameras. So we don't have to worry about USB. Now, retractable, that may be a little tricky. So again, as a developer, we have to worry about all these view and different life cycles. But retractable cameras, that is within the camera domain. I think the expectation can be that the CameraX library will be able to handle all the camera-related events. So as a developer, we don't have to worry about the different camera being plugged in or the different cameras being retracted. That is within the CameraX library domain. We don't have to worry about it. So that's what you can do as a developer to handle all these different issues. Or you can just forget about everything I said and use the AutoFit preview builder that we have in the sample. We basically have a proof of concept implementation of everything that you need to do, which is ready to copy paste into your apps, and it handles all those different cases that we shown earlier. The goal is to keep this up to date, and we are obviously open to feedback, open issues on GitHub if you find any problems with it, but the goal is for you to just be able to use this without having to worry about everything else. That's all for us. Thank you for coming. If you have any questions, we'll be at the Google booth right down there.